Welcome to the Math Record. Today I'll be covering the ICTM Regional 2018 Division AA Junior Senior 8%. I'll be covering questions 6, 10, and 11 in this video, and then the next video I'll be covering questions 14, 15, and 18. Okay, so I'll take a minute to scroll down all 20, and that's all 20. So let's begin with number 6. So in the following representation, a and b are digits where a is not equal to 0, then x can be defined, it can be expressed as a, and x is also the product of three consecutive prime numbers. So we could say x is equal to 1000a plus 100b, right? Because they're in digits form, we could write this as algebra in some kind of algebra. And this is 10b plus a. So combining our like terms, we got 1001a plus 110b, and they're both divisible by 11. So that makes 99 minus 1, so that's a 1, and a 1, that's 11, so that's a 1 here. So 91a plus 10b. So I know that one of the primes has to be 11. That means if 11 is at the end, the next highest is 13, and then not 15, then 17. If it's 11 in the middle, then 13. 9 doesn't work, so 7. And if 11 is at the end, that's 7, and then there's 5. So these are three possibilities because it says three consecutive prime numbers. So that means it could be 13 times 17, which is 21, 3, 10, 12, and then 2. So 221. So that means 91a plus 10b is equal to 221. And a is only a way to get a unit digit because this is in multiple 10. So that gives us that a has to be 91 because the next one would be 182, which doesn't work because this is a 2 and we need a 1. So if it's 91, that means this would be 130 left over. So b has to be 13, which doesn't work. So that tells us that the first possibility doesn't work. Now let's try this one, which is 9 times 13, which is 91, which is basically this. So 91 times this 11, well, what is that? That's 1001. So that works. So we have, because that would be if a is 1 and b equals 0. So we know that that works. That would be 1001. Okay, now we get 5 times 7, which is 35. Does 35 work? Well, no, because 91 is bigger than 35, so A has to be equal to 0, and B does not have a unit digit, so it can't make that 5 in that 35. So this doesn't work. So the only value that works is 1001. And that is your answer for number 6. Okay, number 10. Let m equals 1 over 8 factorial and n equals 1 times 1 factorial plus 2 times 2 factorial, basically all the way into 9 times 9 factorial plus a 1. Determine the product m times n. So what I like to do is that since I kind of see this pattern, I like to write what in general form. So x times x factorial, basically, right? And x goes from 1 to 9. Right? This is 1 times 1 factorial, 2 times 2 factorial, and all the way to 9 times 9 factorial, plus the extra 1, which is kind of irregular, but we'll figure that out in the end. So what I like to do when I see a factorial is that I like to make it into 1 factorial without anything else. So how do I work with this? Well, instead of x, let's say this is x plus 1 times x factorial. Well, that doesn't make sense because these two are not the same, right? They're not the same. But let's distribute it out and see what is happening. So this would be the same as saying x times x factorial, which is what we have. And then we have an extra x factorial over here, right? So for this to be the same thing as this, all we have to do is just take away that x factorial. So all we have to do is just subtract a x factorial, and that will finally make it equal to x times x factorial. So basically, we have x plus 1 times x factorial, which is basically the same thing as x plus 1 factorial, right? Because x factorial is just be like 1 times 2 times 3 times 4. And if this is like 4 plus 1, that's 5. So 1 times 3, 1 times 2 times 3 times 4 times this, now 5. Well, that's just 5 factorial, right? So we could just rewrite like this, minus x factorial. And that's equal to x times x minus 1. And we know x goes from 1. So if we plug in some values to see what's happening, we plug in 1 here, that's 2 factorial minus 1 factorial. Now we plug in 2 in here, that's 3 factorial minus 2 factorial. And then we plug in 3 3 in here, that would be 4 factorial minus 3 factorial. And then we plug in 4, that's 5 factorial minus 4 factorial, and etc., right? All the way until 10 factorial. Okay, dot, 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 all the way until 10 factorial minus 9 factorial. So what's happening? Well, this 2 factorial cancel with this one, this 3 factorial cancel with this one, this 4 factorial cancel with this one. And what you see is that a bunch of these numbers over here starts canceling out with the ones that are negative. So that means all that's left would just basically be this value and this value, right? Because those are the only ones that don't cancel. So that means it's 10 factorial minus 1 factorial. And 10 factorial is basically 10 factorial. 1 factorial is just 1. And that's why there's just this extra plus 1 in the end. Because then it cancels out with this one, would give us 10 factorial. And that is our value for n. So our value for m times n is just 10 factorial divided by 8 factorial, which is 10 times 9, which is equal to 90. And that is our answer for number 10. So just think about a general solution and kind of solve it. And now number 11, w, x, y, z are positive real numbers, and then basically the system, find the product of x times y times z. So I noticed that the last one has a value while the first three don't. So that basically tells me that the first three we're trying to find relationships. And the last one we're going to have to find a value. And then from that value, we could plug it in to get our x, y, and z's. So that's going to be our, like, basically our game plan. So so let's work with our first three. So let's simplify so we could get some values. So I see that they all have w's. This is a y, this is a zy, this is a zx, and this is a xy. It doesn't matter which one you like to use, but as preference, I usually like to use x and y's. So I'm gonna have this as my original, and I'm gonna combine this equation with the first two equations, so wz plus wy, and then this is yz. I like to put them in order, and this is 2wz plus wx is equal to xy. So I want to cancel out some variables here. So I noticed that they both had wy. So let's multiply this equation by -2 and then add it to this one. So this would be 2wx minus 4wz is equal to xy minus 2yz, right? Because just multiply this by -2 and add. And I'll do this. And then we have wx here and wx here. And I just need to multiply by -2 in this equation and then add. So that'll be 2wy minus 4wz is equal to xy minus 2xz. So basically, I just did a regular system equations, and now we got these two. And now, what can we cancel out? We could cancel out this wz. So we could just subtract the first equation by the second one. So that's 2wx minus 2wy. The xy minus this xy, so we get 2xz minus 2yz. And then we could basically cancel out the 2's and move everything to one side. So that's wx minus wy minus xz minus yz is equal to 0. So I could distribute out our w, so that's x minus y. From here, I could distribute out our negative z. So then I could also get here x minus y. Oh, sorry, this is minus, so this is a plus this side. So then this is x minus y, and that's equal to 0. Right? So then this gives us that w minus z is equal times x minus y is equal to 0. So either w minus z is equal to 0, which is equal to w equals z, or x minus y is equal to 0, which is equal to x is equal to y. So one of them is true and the other one's false. So basically, which one is going to be true? Well, all we have to do is just look at the first few equations, because that's what we simplify from. So 2wz plus wy is equal to zy. So let's plug in w is equal to z. So that means this is 2z squared. Zy is equal to zy. So that subtracts up to 0. So 2z squared is equal to 0, which is not true because z cannot be equal to 0. So because it's going to be a positive number, and 0 is not positive. So definitely from there, this is not true. So that means x is equal to y. Okay, so now let's plug this back into one of our equations. So 2wx plus wy, those are the only ones with x and y's because I don't want to work with the z. So then 2wx, and let's substitute our y with our x, so 2wx, and then this is x squared. So that gives us the 4wx minus x squared is equal to 0. Distribute our x, so that's 4w minus x is equal to 0. X cannot be equal to 0, so that means 2w minus x equals 0. So that means 4w equals x. So then that gives us that x is also equal to 4w. Okay, so we know that is true. And now we need to find the relationship with c now, because we have 3 out of the 4 variables. Okay, so we have 2 times, we know we know that w is equal to 1/4 of x, and then times the z, plus w and y. So our y is equal to our x, and our w is equal to 1/4 of x, right? And then we have z uh, multiplied by our y, which is also equal to our x. So that gives us that 1/2 xy plus, xz equals to 1/4 x squared is equal to xz. So xz minus 1/2 xz, that means it's just 1/2 xz here, and then 1/4 x squared. And then basically, we could kind of move them to one side, so 1/4 x squared minus 1/2 xz. So we distribute out a 1/4 in our x. We have x minus a 2c. Okay, so that means we know x cannot be equal to 0. That means x is equal to 2z also. Okay, so now we found the relationship between all 4 of our variables. And now we could plug it back into our 4th equation now. So now our 4th one. So 2 times our x times a z, our z is 1/2 our x, plus 2 times our y, which is x, and our z is 1/2 x. And now we're x, and our y is equal to our x, and that's 1,200. So 2 and 1/2, that's just x squared. 2 and 1/2, that's x squared, and this is x squared. So this is 3x squared equals 1,200. That means x is, so divide by 1,200 divided by 3 is 400. Square root of 400 is 20. So that means using this, that means y is also equal to 20. And z is half of x, so that would be z is equal to 10. Now we can multiply them all together, and that gives us 4,000 for number 11. And that basically covers the first part of our video. And here are the answers for all 20. Well, thanks for watching, and I'll see you at the next math record.